that we're going to cover today. Scientific visualization. So we are going to look at ParaView as the tool that we're going to use to explore scientific visualization. This is just a screenshot from the course webpage. If you haven't already navigated to that page, I encourage you to do so now as we start to move into today's session. So for today, we will talk about scientific visualization, what it is, try to define it to give you, again, a starting point and some ideas about what scientific visualization is. We talked about over the last 2 days the information visualization process, or the 7 stages to visualizing data. And during that time, I mentioned that regardless of what type of visualization you're doing, each of those pipelines or those processes will incorporate many of the same steps that we went over for the information visualization series or webinars. So you will see some commonalities. I hope that you will see some commonalities in the pipeline that we're going to look at today. We will then explore some common scientific visualization techniques. We will do that by introducing ParaView, and we will have some hands-on exercises that you can work through as we go through the slides for today. So just to recap again, this is the data visualization process that I mentioned before. And as I stated, there are 7 stages that I outlined to this week that we looked at. And each of these stages will be represented in some form or fashion in the scientific visualization process as well. So I'm just listing this or showing this just as a reminder to show you these are the stages, and hopefully you will see some similarities in the process that we're going to go over for scientific visualization. Remember, it is an iterative process, and so very much so with the tool that we're going to use today, you will see that it very much is an iterative process. We will make several edits and revisions and apply different filters. And so that speaks to that iterative process that I mentioned, I'm indicating here, and also mentioned in the previous webinars. So what is scientific visualization? Scientific visualization is primarily concerned with the visualization of 3-dimensional phenomena. We have all seen scientific visualization techniques applied to maybe different areas that you may not have thought about, specifically in the gaming industry. So many, if any of you are gamers or you play video games or you like video games, I'm sure you are aware of the realistic viewing of those characters or the environments. And so many of the techniques and tools that are used in the gaming industry in animation are also used in scientific visualization, because we like to see that realistic view, that high resolution, that 3-dimensional aspect of the visualizations that we're creating. So you've seen this in some form or fashion before, but maybe you hadn't thought about it in that way. So with scientific visualization, the emphasis is on realistic renderings of volumes, surfaces, illumination sources, and so forth, and perhaps with some dynamic time components as well. So we talked briefly about maybe having a time component in the data, the previous types of data that we looked at this week, but there could also be some time component with scientific visualizations as well. So this is our scientific visualization pipeline. And so I'm hoping that you, again, while you see that there are some similarities, some similar things in this pipeline that are also evident in the previous pipeline that we've looked at. For example, getting that input data, preparing that data, using scientific visualization model data, and we'll talk about what that is shortly, using or applying computer graphics data, and then also finally creating the image that you will ultimately view at the end of this pipeline. In this particular slide, I'm showing, or it's showing on your right, steps that are actually, or tasks that are actually being performed as you walk through this pipeline. So when you produce or you generate your input data, The next step is to analyze or filter or format that data. And so once that happens, the data could be considered to be prepared, which means that you're preparing that data for the next step, in which you will apply scientific visualization techniques. We will talk about what some of these techniques are momentarily, but then there are some additional steps that maybe we did not see in the previous visualization 7 stages process that we looked at yesterday and the day before, such as mapping to geometry. And so this is a specific task that is specific to scientific visualization that may not be included in the previous framework that we've looked at yesterday and the day before. Once we map the geometry to the data, or map the data to the geometry to give it some form, some shape that we would like to see the data represented in, we then move on to the rendering process, or sometimes it's called post-processing. This allows us to actually create a visual of the data that we've been working with in this pipeline, which leads to actually viewing the results. So if you haven't already taken a look forward to the next slide, what is missing from this pipeline? It is that critical step that I mentioned yesterday, getting critiques or getting feedback. This is a feedback loop. And so what will be helpful for you in terms of generating the visualizations that we're going to look at, and for many of you who will benefit from using scientific visualization applications to help visualize your data, it is very important to get that feedback. And also, sometimes you will be giving yourself the feedback because you will be creating visualizations in a 3D window in ParaView, and you will be able to examine that visualization and determine if further steps are needed or if you need to traverse your scientific visualization pipeline. So we will be creating some pipelines today in this session, and you will be able to visually see the steps that you are taking to create the pipeline. So one question that you may have, or you probably will have as we go forward, will the pipeline look the same every time? And so it is going to depend on the steps that you take, the different filters that you apply, that you determine that you need. That is going to determine what your pipeline looks like. The nice thing about ParaView is that it will create a visual display of your pipeline. And so if you want to go back, traverse it, and see what you did in order to create the visualizations that you will see, you will be able to do that. It creates a visual representation for you. So that's something that is really nice about that. So now what I want to do is to walk you through this pipeline. And so just a reminder, this is the visualization pipeline that we're working with today, and we're going to step through each one of these stages fairly quickly, but just to give you an idea of what is happening or could be happening at each of these stages. So in stage 1 or step 1, produce data. This is where you would have different types of data. So we looked at what I called information visualization type data before. Now we're looking at more scientific related data. It could be simulated data, it could be images, it could be numerical, it could be some measured value or some phenomena that you have observed where you are collecting or gathering this data. So this is the first stage. If you think about the previous stage, this would be our acquire stage. Once you have the data, the next step is to analyze, filter, reformat. And if we're thinking about the previous 2 days, this would be our parsing stage. So this would be where you would clean up this data. You would remove any noise that you might have or identify and replace missing values. And so we talked a little bit about data that may be missing in the data file, or in the case of yesterday, we looked at having a -1 value, which could represent missing data. So missing data may look differently depending upon it may be looked upon how you represent it in your data. It may look different, but this is the place where you would address it, where you would figure out what's missing and then how you're going to represent that data. This is also the stage where you may have to clamp your values to a specific range of interest that you're looking at. More than likely, your data sets will include a lot of data, some of which you will use all the time, some of which you will only use in certain instances. And so what you may want to do is to figure out what ranges of values that you're interested in, and it is in this stage where you would clamp those values or identify those specific ranges that you're interested in. This is also the steps where performing operations to yield more useful data takes place. So this is that filtering. You're going through and you're preparing this data in order to be analyzed, and you're reformatting it, getting it ready to be read into the application that you're going to use. Once you have analyzed the data, you have filtered it, you've reformatted it, the next step is to apply those scientific visualization techniques that I mentioned. And at this stage, this is where you will, or the application will, convert the raw information into something that is more understandable. So it is likely that some of you will deal with different file formats. We looked at very simple file formats over the last 2 days. Some of you may have TIFF files, or you may have file formats that you have created yourself, and you can do that with your data. One of the nice things about ParaView is that you can write a reader to read your data. I'm not sure that we will have enough time to go into that much detail for that today, but I just wanted to make you aware of, if you have a file format that is not recognizable by ParaView, which they have taken great measures to incorporate many different types of file formats. So it's highly likely that your file will be able to be recognized by ParaView. But in the event that you have created your own file structure, you can write a reader to recognize your file format. Of course, that is going to take a little bit more effort on your part to do that, but it can be done. So it is at this step, step 3, where we visually extract meaning from a scientific data set using various techniques. And here are some of the commonly used techniques that you should see in any scientific visualization tool. Should have these basic techniques available to you. If they do not, then I would strongly encourage you to find one that does, because these are considered to be, like I said, basic, and they should be present in any scientific visualization tool that you use for visualization. And so we're going to look at some of these, not all of them today, but some of them we will. For example, contours and clips, and creating glyphs, and setting some values to set the threshold for the data that we're going to look at. But this is just, again, a starting point to let you see the different various types of techniques that can be implemented and applied to your data. The next step, step 4, is to map to geometry. So up to this point, we've just been looking at the data, getting it, preparing it for being able to read it into whatever application that you're going to use, and in this case, ParaView. But what kind of structure can you use or represent your data in? So ParaView will recognize many different types of geometries. These are some basic ones I provided here on this slide. So you can have scalars, vectors, and tensors. It can do or recognize 1D, 2D, 3D types of visualizations, or types of geometry. You can do a mesh. It will look at point data, cell data. And again, this is just examples, a few examples. ParaView is a very powerful package, and so it will enable you to look at different types of data in different formats as well. The next stage or step will be to render or post-process. So a lot of the things, everything that I've talked about up till now is considered pre-processing. So you are getting your data ready. And so once you have completed all the previous steps I just mentioned, you are now ready to render. And if you think about over the last couple of days, one of the things we talked about is that up to a certain point, before we would actually render or represent, that I think that was the term that was used, we had not created any visualizations. And so following in that same process or procedure, Now we are ready to render or to post-process the data that we've been working with. And again, I want to reiterate that the data visualization process is an iterative process. It requires a lot of refinement. And one of the things that I've said over the course of this week is that your first visualization will not be your last visualization. And we will see that very much so during today's session and as you go forward, creating your own visualizations. Lastly, after you have worked, meticulously through this process, you're able to actually view the fruits of your labor in the sense. And so here are some examples of different types of views or outputs that can be generated using ParaView. You can apply pseudo-color renderings to, again, point out things that are of a particular reference or interest to you, to highlight different aspects of your visualizations. You can use tensor or vector glyphs. Parallel coordinates, I kind of highlighted that one on yesterday. You can also use streamlines, and of course, one of the things that allows you to do with ParaView is volume rendering. So there is a lot of things that can be done with ParaView. Again, it is a very powerful package. It is open source, which is very good because that means you have access to it at all times, and they do a very good job of maintaining the the versions of the software, and I think there are online groups that you can join. There's documentation. They've done a very good job with making sure that this is a highly used tool. So visualization scales with high performance computing, HPC. Large data produced by large simulations produce large visualization results and require large visualization resources. And as I mentioned in the previous lecture, it used to be said, and it still is, that a picture is worth 1,000 words. However, now we have to start thinking about how are we going to store those pictures or those large images. And so if you think about the amount of data that is being generated, terabytes of data, at least terabytes of visualizations when you're resampling and you're looking at applying different filters. And you will see this as we look at one of the data sets today, that depending on the size of your data set and the resources that you have available to you, in particular if you're running it on your laptop, sometimes these images or these modifications and filters can take up a lot of the resources. And so if you notice some slowing down in terms of the speed of your laptop, and you have these large images, you may want to consider high performing computing resources to help you with the visualization aspect of that. So the resolution to capture and feature detail, that's another issue that we have to think about as you start working with large data sets. Where do you want the processing to take place? Do you want it on a high performance computing environment, in that environment, or can you do some of it locally and then push it to another system once done? So we're not going to go into a lot of detail in that aspect today, but I just want to make you aware of the resources and the types of things that you should be thinking about as you are creating and using your visualizations using ParaView. So ParaView is, the backbone of ParaView is the Visualization Toolkit, VTK. Some of you, I'm sure, may have heard of this. If not, it is an open source multi-platform application that supports distributed computation models. And so this may be of significant interest to you because, again, as I mentioned, as you start to increase the amount of data and the visualizations that you're creating requiring a lot of data or just being made up of consisting of a lot of data points, you may need to think about how am I going to utilize, or what can I utilize that will allow me to continue to work in a timely and efficient manner to create the visualizations that I need. So VTK is available for 3D computer graphics, image processing, and visualization. It is a collection of C++ libraries leveraged by many applications and divided into logical areas, specifically filtering, information visualization, volume renderings. And so there's a lot that you can do with this package. If you are inclined to write your own code, there are Python shells and different tools and commands that can be used with that. Again, in my overzealousness for today, I was hoping to include some of that in this workshop. I'm not sure if we're going to have enough time. If we run out of time, then I will try to still make that content that I was going to share with you available on the website so that you could, at your own leisure, take a look at it and see if that's of interest to you. So ParaView is an end user application with support for parallel data archiving, parallel reading, parallel processing, parallel rendering, but you can also run it on a single node or on your desktop. And so I am hopeful that you have, for those of you who are interested in working along with the webinar today, you have downloaded ParaView and hopefully you've taken a look at it. We will do some hands-on loading of files and looking at some things to get you familiar with the application. Like I said, it's a very powerful package. You can do a lot of things with this. You can install it on a server. You can use MPI clusters for rendering. I mean, it is a very robust application. And so your interest in this webinar and hopefully in the software itself, I think will prove to be beneficial to you as well. Here are some more features I want to point out about ParaView. It does have a standalone GUI. It is scriptable with Python. So if you're familiar with Python or comfortable with it, again, as I mentioned a few slides ago, if you are interested in creating or writing your own reader to look at your own type of data formats that you created, you can do that using either C++ or Python. It allows you to embed graphics windows into custom GUIs, and it also has plugin architecture as well. So again, these are just a few of the features. There are way more there in the package itself, and I do encourage you to go and take a look at the documentation and the website for ParaView, as it will give you a far more extensive introduction to the many, many features that are available. So at this point, what I'd like to do is to start with the introduction to scientific visualization using ParaView. It is a multi-platform data analysis and visualization application. As I've been saying, it is a mature, feature-rich interface. It's good for general purpose rapid visualization as well as for research applications as well. One of the things that is nice about it, ParaView, is that it is a multi-platform application. So if you're a Mac user, or Windows user, or Linux user, you should be able to locate and download and install a version of the software for your particular platform. The nice thing about this is, regardless of which platform you're using, if for whatever reason you should switch environments, the environment or the application should look similar. So you should be able to still navigate and use the application regardless of the environment that you're using, which is always nice. Funding for the ParaView application and the consistent upgrades and updates is available through these funding sources that I have am displaying here on the slide. And then I also want to point out that many of the slides that I'm using today are from Kitware or Sandia National Laboratories, which is where the software is maintained. And so what I've done is adapted many of the slides to fit for this webinar. And so you will see the logos, and I want, of course, to give credit to where this content is coming from. So let's talk about data ranges. So again, we're looking at different types of data here that we're going to be looking at and utilizing for scientific visualization. And so this is just some of the landmarks of usage of the application. It kind of gives you a feel for how the application has grown and how it continues to grow to incorporate algorithms that will allow for and functionality that will allow for the inclusion of larger and larger data sets. So you may be thinking, oh, my data set is too big. I'm going to encourage you to give it a try. Don't make that decision before you try getting your data into ParaView, because you may be surprised that it may be able to handle it. So this is the ParaView application architecture for those of you who are interested in knowing pretty much the backbone of ParaView and the things that it is, applications that it is built upon. So you have OpenGL, MPI, ICE-T, and many, many more that the functionality of these things are incorporated into ParaView. And so there could be a ParaView server if you're using ParaView at your university that has it installed maybe on a cluster. And so I would encourage you to get familiar with ParaView and then reach out to those resources at your university to see what type of assistance or other resources, other features that they may have installed and available to you under the ParaView application. So again, this slide needs to be updated. So you can see at the bottom it says ParaView 5.4. Today we're going to be using ParaView 5.8. So this is just to, again, hopefully to show you the progression of development of the application, and to let you see that it does have a long-standing existence here in the data visualization community, specifically for scientific visualization. So I want to go over some of the different types of data types that are supported by ParaView. You may or may not use all of these, or you will use at least one in order to get data into ParaView. But it's always good to know what are the other different types of data types that are supported by the applications that you use. And so the first type is a grid, which is considered to be a regular structure. All voxels or cells are the same size and shape. It is a uniform rectilinear grid, and it could be either a 1, 2, or 3-dimensional array of data. So the points are orthonormal to each other and are spaced regularly along each direction. And so for each of the slides that you're going to see in this section of the presentation, I've tried to provide a visual example of what that data might look like after it is read into ParaView and a visualization is created. So this is some examples to go along with what it looks like to ParaView in the upper left corner, and what a visual rendering of that data would look like to you and I once it is rendered in the lower right corner. The next type of supported data type is something called a curvilinear or a structured grid. So you have structured data and unstructured data. And that's one of the things that makes ParaView a very widely used tool, is because it will recognize both structured and unstructured data. So if you look at, or if you see in there, a curvilinear structure or curvilinear grid in the upper left corner, this gives you a schematic of what that might look like in behind the scenes in terms of how ParaView views that data. So curvilinear grids have the same topology as rectilinear grids. However, each point in the curvilinear grid can be placed in an arbitrary coordinate, provided that it does not result in cells that overlap or self-intersect. So a curvilinear structure is a regularly gridded mesh shaping function that is applied that allows you to see curvature. And so the curvilinear grids provide a more compact memory footprint and implicit topology of the rectilinear grids, but it also allows for much more variation in shape of the mesh. And so as I've shown in the lower right corner here, hopefully you can see that it does have more curvature than the previous slide. And so this again gives you a lot more flexibility and opportunities to look at different types of data and to see more detail in that data. So I mentioned having structured and unstructured data. So ParaView allows for something that's called an unstructured grid. And for some of you, this may be the way that you will read in your data. And so if there is some irregularity to the data, maybe an irregular mesh, this would be the type that you would look into in terms of trying to get that data in, at least for an initial stage of starting the process to visualize that data. So it's considered to be unstructured data sets that could be composed of points or lines or multidimensional shapes, anything that is nonlinear. This would probably be what your data would be classified as or looked upon as you try to get it into ParaView. Again, very powerful package that it would even allow you to do this. And so some of you will find this to be very helpful in actually getting your unstructured data or complex data into a format that can be recognized. So we talked a lot about different types of complex data shapes, but it can also do simple things. Point data, polygon data, images, time series support. And so I want you to be thinking more broadly about what are the different types of things that you can do, maybe with your data. Do you have the type of data that will support the different types of things that you would like to do? These are questions that you should be thinking about right now, if you haven't already, and then start thinking about how you might go about either simulating the data or getting some data to play around with that will allow you to explore these many features that are available to you in ParaView. Here are some supported algorithms. Again, I showed a previous slide, which I said any data visualization or scientific visualization application should have, at a minimum, this functionality. So you should be able to do or create ISO surfaces to apply cutting planes or clipping planes, to do streamlines, volume renderings, and these are all things that you can do in ParaView. Again, this is not an extensive list, just to kind of get you ready for what we're going to be doing shortly. ParaView also has some special features. It supports derived variables. Some of you will be creating your own variables when you're working with your own data. That is perfectly fine. Of course, there might need to be a little bit more motivation in terms of writing some code to allow to tell ParaView what to look for and how to actually recognize your derived variables. But again, it can be done. It is scriptable with Python. If you don't know Python, that's fine. If you do know Python, that's even better, because it is if you want to actually create to write some code to visualize your data. You can create animations with ParaView, and you can save those animations. You can run your visualizations in parallel or in distributed mode, depending on the size of the visualizations. And again, these are more advanced topics that we won't cover today, but I felt that you still need to be aware of them so that in the future, should your research take you in that direction, then you do know that you have some options with ParaView in terms of visualizing your data. As I mentioned before, ParaView recognizes and supports numerous file formats, and this is, again, just the tip of the iceberg. This is just a screenshot. It's not extensive. If you are interested in finding out what other file formats are supported, I encourage you to take a look at the ParaView website and also the documentation that they have online. Tutorials and handbooks that will provide a more extensive list than what's provided here. If you don't see your file format on this slide, again, this is just a snapshot. You should be able to see if it does support it, and if it doesn't, do not dismay. You can, again, write your own reader so that it could be, your data could be recognized in ParaView. So we're going to talk about now the visualization pipeline for scientific visualization, specifically for the ParaView interface that we will be working with. So all processing operations are called filters, which we will apply, produce data sets. And those data sets or subsets of your original data. So the first thing you'll need to do is to actually read your data in, and then we will apply filters, and those filters will filter out parts of the data that you specifically state that you want to be rendered or you want to look at. You can further process the results of every operation to build those complex visualizations that I mentioned. For example, extracting a cutting plane or slicing through a plane, applying glyphs. If you're unfamiliar with the term glyph, it is a vector that has magnitude and direction. Vector arrows, for example, are representations of glyphs. You can apply those to the result to provide more detail regarding what the visualization represents. So if you want to show flow of points or data in a certain direction, those glyphs allow you to do that. And it gives you the plane of the glyphs through your 3D volume a little bit more detail and effect, so that as you are maybe presenting the data or for your own use, looking at the data, trying to make sense of it, applying glyphs help to give you a little bit more definition and understanding of that data. So there are 3 basic steps that I want you to remember as we are using and implementing ParaView in the next couple of slides. Read, filter, render. So first, you must read your data into ParaView. Once you have the data into ParaView, the next step is that you may apply any number of filters. And those filters, they process the data to generate, extract, or derive features from the data. And we will look at a few of them today. Finally, you will create a viewable image or rendered image from the data. And so these are your basic steps. I want you to remember 3 things with ParaView. You need to read the data, you need to filter the data, and then render. Those are the 3 things that we are going to do in a very repetitive state today, and that you will do also as you start to work more closely with your own data as well. So let's see here. The next step is to get started. So we are working with ParaView version 5.8. If you haven't already downloaded ParaView, then I encourage you to do so now. If you haven't already downloaded the data files, I encourage you to do so now. If you had already, like I said, bookmarked the webinar website, you should do a refresh and you will see some additional files have been added. There is a zip file as well. I'm not sure if you will be able to download it. If not, just let me know and I will make that file available to you. Those additional files in the zip file will be files that we will look at if time permits today. If time does not permit, then you will still have access to it, and I will create maybe a short video walking you through that process of that content that we don't get to today. So this is a snapshot of the page 3 from the webinar webpage. And so if you will go there, and if you will, go ahead and start up ParaView. I am going to try to, at some point, do this along with you. But for now, I'm just going to point out the basic usage of ParaView. Once you open up ParaView, you should see, for the very first time, you should see this opening startup screen. And it gives you a link to a getting started guide, and it shows you some sample visualizations, which is really nice. A long time ago, they didn't have this feature, but it is very nice to see it now. So this way you can get a feel for the different types of visualizations, some of the similar examples to what I've already highlighted or taken snapshots of in the previous slides. This will allow you to do that.
Dr. Bird, I'm sorry to
Yes.
interrupt.
Oh, no.
But so the additional data files that are
Mm-hmm.
on the link,
Mm-hmm.
it's a bad link. So
Okay.
just to let you know, the only ones that are available are the heads Q, the VTI, and then the rec grid 2.vtk. So I don't expect you to fix it now, but just so you're aware, so you don't
Okay.
switch to those.
Excellent. Thank you so much. Yes. So, like I said, in my haste to try to make it available to you, there may be a typo in the link, but I will definitely fix that. Thank you so much. I'm making a note now to fix the link. So, and basically, if you have already downloaded those two files, then that's what we're going to work on to begin with. And then if time permits, and we have enough time for me to take a look and fix the link, I will. But for now, we will continue as planned. But just know I will go back and make that available to you. So this is what you should see if you've already opened up or started ParaView. You should see something that looks similar to this. You can, have this open up every time, or you can just click that little checkbox in the lower left corner of that little screen and say, "Don't show me this again." But you can close it out when you're ready to do that. So this is what your interface should look like. You have, I want to point out several features for those of you who are not familiar with ParaView. So you have your menu and toolbars at the top. You have your standard Windows window. We have something called a pipeline browser. So I just walked through those several stages of the scientific visualization pipeline. As we walk through this process of adding data, loading data, and applying filters, you will see objects appear in that window that says Pipeline Browser. This will become very useful to you because as you start applying different filters, some things will work as you intended, some will not. Sometimes you will do things as humans do and not know what did I do or how do I get back there. And so this pipeline browser will show you every step that you've taken or the path that you've taken, so that if you want to repeat it or if you want to update it somewhere along the way, you will know exactly how to get there and what part of that, what piece of that pipeline content to edit. There is the properties panel, which we will be looking at a lot today. There is something called the object inspector. And so this will be where you will be setting many of the features and applying different aspects and adjusting different aspects of what you will see in that 3D viewer, as you could see in that window there. So the 3D viewer is where your visualizations will appear. And it is also where you can explore the data. Because it is in 3D, you have the functionality to be able to rotate the data, to take a look at the data. And I will encourage you to take a look at the data, rotate it around, take a look at it. When I say that during this presentation, that is exactly what it means. As it sounds, explore. Do more than just look at it. Rotate it around, turn it upside down, look at it in different planes, because that's how you get a really close view of how the data is represented. And it's pretty cool as well. There's also something called the advanced toggle. And so as we work through the steps that I've outlined in this presentation, sometimes you may or may not see many of the features that I'm talking about or that I refer to. If you don't see them, use that toggle to make them appear and disappear, and they will appear and disappear below that search box there. And so we'll get back to that and we'll talk about, we'll type in some things to let you see what happens there. But if you ever lose your way and you don't see something, particularly a feature, use or make sure that you check, maybe toggle between on and off the different features or functionalities that's below, aspects that are below that search box. So these are some basic things that I'm pointing out now. I will point out more as we go forward, but this is to get you familiar with what you're going to see. Okay, so Sometimes we click on things and they will disappear, and you might say, where did my pipeline browser go? It disappeared. I don't know what happened. So if you click on the View tab in your toolbar, and then click on Toolbars, you will see another menu that will open up, and you could check to see if the thing that you're looking for, or the feature that you're looking for that has magically disappeared somehow, then you can check to see if it is in fact unchecked. And so that will should bring it back to your display so that it would be visible. So I'm sharing this with you. I'm going to share a few things, like I said, in case you you lose your way, because what's going to happen as we go forward, and what I'm going to encourage, is that you do explore the different features. You can either go along with me, or you can go ahead and start looking at things. Just be aware that as you are exploring things, and I encourage you to do that, your outputs will look slightly different from what I have, the screenshots that I have captured here. And so if you need to readjust, the slides are there to help you to figure out what you would need to do to get you back to where you're comfortable with either starting over or starting again or adding new features as well. So let's do something. I've been talking a lot, so now let's create something simple. So ParaView provides several different types of geometric shapes. And so if you click on the Sources tab and then click on Geometric Shapes, you can select any of the shapes that they have there. For this section of the presentation, I'm going to ask that you click on the cylinder, but again, you can go at your own pace or select a different shape. The features that we're going to explore should apply to whatever shape that you choose. But for the purpose of following along, if you select the cylinder, what you should see is a new object appear in your pipeline browser. And by default, it's called Cylinder 1. For any of the objects that appear, you can change the default names. And so that's another nice feature of this. And so although I'm going to keep the default names, if you want to at any time to rename those as you get more familiar and comfortable with ParaView, then all you would have to do is to click on the object. And then once it becomes available, you can just rename it, type a different name that you may feel that it's more suitable to what you're doing. So once you click the cylinder, it should create a new object, put an object in your pipeline browser. Click the Apply button to accept the default parameters. Now, some of you may have, something may have already appeared in your 3D window, maybe not. I am going to proceed as if it has not, so that you would know what you would need to do if it doesn't show up. So if it doesn't automatically show up in your 3D viewer, there is an Apply button. And so clicking that Apply button forces the application to apply whatever changes you have implemented. And this will become useful because, like I said, you will be applying different types of filters. I'm also going to show you in a couple of slides how to set the settings so that your edits or your filters are applied automatically, and the results appear automatically. But we will get there shortly. So this is to show you how to do this if in fact you apply a filter and you are confident that you did it correctly. You clicked on the right filter and it should be showing you something, but it is not there. If that is ever the case, then perhaps what you need to do is to tell the application, tell ParaView to apply your latest filters that you have applied. So you should see something. Sorry for that high pitch soul there, but you should see something now in your viewer. And so what we're going to do is we're going to play around with some of the features here. And so what I'd like for you to do is to explore the resolution feature by adjusting the resolution slider. There are always multiple ways to do anything, and with many of the applications, you can either use the slider or you can actually type in a number. And so you should see the default number at 6, which shows you something. You should be seeing something in your viewer now. If you don't see it, Then again, click that apply button. In my case, it is grayed out because the filter has already been applied, and so if it's already grayed out, then you should see something in the window. So I want to point out a few features, more features, and I will do this as we go forward. So there are some simple camera manipulation features. You can rotate things. You can change the view from different axes. You can expand. You can rotate. Again, rotate. You can rotate by plus 90 degrees or minus 90 degrees. So you can do this with the aid of one of these buttons, or if you have a mouse, and if you're very comfortable using a touchpad, which I am not, you can also apply these different functions and features as well. But if, again, I'm sharing this with you because as we start to apply filters and things get a little bit more cluttered in your 3D viewer, you may want to reset your perspective or the orientation. And so these buttons that are located at the top of the window, the menu, will allow you to do that. So in your pipeline object controls, in your pipeline browser, you should see 3 buttons, one that says apply, one that says reset, one that says delete. We've talked about the apply button. If you have applied a filter and you don't see the results, or you don't think that you see, or they haven't been applied automatically, if you click the apply button, that should force it to apply the changes or the filters that you have indicated you want it to be applied. There's also a reset button. So we are actually going to use this momentarily, but you may need to do that at some time. Sometimes it may get very complicated, or you just may lose your thought process or whatever, or can't figure out where you are because you've applied so many different things. If you want to start over, you can do a reset. Now, when you do reset, it will wipe out all of the content in the pipeline browser. So you want to make sure you want to do reset before you reset it. And then, of course, you can always delete something as well. So those 3 buttons will become very useful as we move forward. I talked about being able to, or setting the settings so that you can apply your filters automatically, which means that if you're tired of clicking that apply button, you just want, when you say apply this filter, you want it to just apply it and you not have to go through the process of forcing it. There is a button that looks like the button that's shown here, the icon there, where it looks like a little computer chassis with the outgoing green arrow. If you click that and toggle in between, so if you click on it once, that should in effect tell ParaView that you want your changes to be applied automatically. So try it out. Click that button, change the resolution parameters again, and then what you should notice is that your filters, or the parameters that you have changed, in this case resolution, they have been applied to the data, and you should see the changes in your 3D viewer window. If you don't see the changes, then you can always go to the default or the standby and click the apply button. And it's okay if you prefer to click the apply button. This is just a very nice feature that may come in handy there. So again, also with these slides, what I've done is we're working through steps and exploring different things. At the end of each section, I've tried to create a summary slide. In the event at some point you want to go back through these slides, but you don't want to have to go through every single slide to get to what you're looking for. And so there will be some repetitiveness here, but it's mainly for the purpose of showing you different ways in which you can actually get to the point that you're looking for without having to sit through it all again. So this kind of summarizes what we looked at so far. Clicking on that little icon changes the properties so that whatever filters that you apply, the outcomes of that will be shown automatically. We looked at the setting and playing around with the resolution parameter. And then, of course, this is at the bottom of the slide that's in the red circle. It shows you where on the toolbar you can find that icon. So we have an object in our pipeline, our browser pipeline. So let's take a look at some of the properties there. And so what you will need to do is to look for the tab that says properties and information. And so although I've grabbed just a screenshot, many of these properties are not visible in this screenshot. So if you take a look at over to the right, you will see a little scroll bar. And so I'm going to encourage you to scroll down to see what's down there, just to take a look. And we're going to look at some of those. But for now, this shows you the properties section, and there are display sections and other sections in that particular component of that area there. So what I want you to do is we're going to change those render properties. So scroll down to the, if you don't already see the display geometry representation section, there's a little red arrow on this slide showing you where you can slide down or use the scroll bar to scroll down. And what you're looking for is that little icon that shows a color scale. We want to edit that. And so what we want to do is to click on it. This button is all, if you don't see it there, this button is also located in the toolbar at the top of the window. And so what I want you to do is to click on that button, the edit button, edit color, and select a new color for your cylinder, whatever color you like. At this point, this is where we will diverge a little bit. You may select some features that I didn't select. Again, I encourage you to explore because that's the whole purpose of this. One thing I want to point out is that you may or may not see the axes grids in your 3D viewer window. If you want to turn them on or off, you can always click that little button in the view render view section of the properties. So I have a little call out box there that says, check this to turn the axes grids on or off, and any other features here, explore. Check it, see what happens, see if that's something that you want to include or not. If you decide that you don't want it, you can always uncheck it. So you want to make sure that the orientation axes are visible in the lower left corner. So you should see this icon that shows you the multiple axes, X, Y, and Z, with a little icon that looks like a little eye. And so that's going to show you or give you your perspective. And so if it's by default showing the X-axis coming out towards you and you prefer it to be in a different orientation, you can click any of the buttons that are located across the top of the window that would allow you to do that. So now what we want to do, I'm encouraging you to do, is to click the color palette button to change the colors. And so once you click that, you will have the opportunity to try several different color palettes, or you can edit the current color palette. And that is one of the options. And so in this case, what you're seeing now on the screen, I changed my cylinder to a color of green. And so if I wanted to further edit this palette, you would click on the palette icon and then select Edit Current Palette. And that's will allow you to get your creative juices flowing there. You can apply whatever colors that you think is most representative of what you're trying to highlight in your data. And of course, we're just looking at a little simple rendering here. But as I've stated throughout the week, be thinking about how can I apply these simple concepts to my data once I get it into ParaView. And this is what these settings look like. And so you can change the foreground, you can change what the edges look like, you can change the surface color, lots of things that can be done here. If you decide that maybe you were just playing around and you don't want to keep whatever changes that have been implemented, you can always restore defaults. And so at the bottom of this screen, in that little window, there's a button that says restore. And so there's always a way out to get back to where you started. And if all else fails, you can always just close the application. But I hope to provide you with some tools that will allow you to say what you're working on, because you're working hard on this and you will be working hard on with the data that you're going to be visualizing. So we want to try not to lose any data and try not to lose any time if possible. So here are some advanced properties as well that you can do, that you can apply. So there is a search box there on the Properties tab, and there's something called a toggle advanced properties. And so what the search properties box allows you to do, if you know the property that you're looking for, you can type it in, and it will bring it up for you automatically below in the box there, below the search box. And so this becomes useful because, as I mentioned before, this is just a screenshot that I have captured, but there are a lot more properties below that. And so if you click on the toggle advanced properties that looks like a little gear there, that will allow for the additional properties to show up in that list of properties below what I've shown you here. So take a moment, if you haven't already, click on it, see what happens. When you click on it, you should see an expanded list of property settings, things that you can set in the box below. And if you click on it again, it gives you just a minimum number that you should be able to see. So if at any time when we're working through these slides and maybe the slide says click on or locate some feature that you don't see in that box after you scroll down to look for it, click on this toggle advanced properties icon, and it should show you all of the properties that are available that you can adjust. So this search properties search box is going to be very helpful as well. So we're going to use that. So let's take a look. Let's try some things. So in that search box, I want you to type the word specular into the search box there. Changing the specular value to 1 should make it shiny. And so by typing in the word specular, you should see that the content below the box there, below display geometry representation, should have brought up the content for that particular feature. And so that makes it easy. You don't have to go searching for it. It brings it up automatically. So if you change the specular property to 1, it will make, or it should automatically apply the algorithm to make whatever you have in that pipeline browser, which should be the cylinder 1 right now. It should change it to shiny. So what I want you to do is you can play around with, putting different values in to see what happens. But I also want you to try typing in the following list of different features in the search box, one at a time, which means don't put them all together, don't put them all in at the same time. But as you type them in to explore these properties, as you type in axis grid, what you will see is that that properties section will become available in that section now. You may not be able to see the rest of the things, but that will be at the top there because that's what you typed in. And then, play around with the features there. What can you change? Whatever is there, you have access to. And so one way to learn a tool is to explore. I like to say, think of yourself as a 5-year-old. 5-year-olds always asking questions. What does this do? What does that do? I'm giving you license now to ask that question of yourself and to give yourself approval to explore. So when you type in maybe opacity, so you'll have to remove the previous word that you placed in that search box in order for the next feature to come up. But this will allow you to, like I said, if you know the feature that you want to edit or to change, if you type it in, it should automatically come up for you. So that saves a little bit of time for you as well. So those are a few things. Again, if you take a look at the documentation for ParaView, you will see the entire list, so they will provide you with the entire list of different search categories that you can put in there if you're looking for something specific, so you don't spend a lot of time searching. Things that are helpful: undo and redo. Camera undo, camera redo. Again, we do things. I do things, which is one of the reasons why I put this in here. Sometimes we get lost in the whole process because it is a complex process and it is iterative. And so you want to be able to, have some breadcrumbs, how to get back to where you started. And so knowing that these features are there, very helpful. And you will use them at some point. Whether you use them today or not, you will eventually use them. And so it's always good to know. So here we are, another summary slide. If you're just joining us, or maybe you've gone off and was doing some exploring and now you want to get back to where we are, this is a summary slide, basically following through or providing the steps in a concise manner as to what we've just done. We went through the sources menu, we clicked on geometric shapes, we selected a shape, and in this case it was a cylinder. We clicked on the apply button to accept the parameters, but that was before, of course, we applied, when we clicked on the button to say automatically apply the outcomes from the filters. We played around with the resolution parameter. Again, if you apply a filter and you don't see your outcomes or you don't see the results of that filter in your 3D window, click on the apply button if needed, and that should force it to apply the changes that you've done. So now we've walked through all of that, and hopefully you have a cylinder in your pipeline browser. And now I want you to delete it. I know for some of us it's like, really? Do I really want to delete? Yes, it's okay. So if you make sure that the cylinder one object is highlighted or selected. That means it should have the little blue background behind the word. And then just click on the delete button or just press the delete key. We want to start with a new setup here because we're going to do something new. So again, if you haven't already downloaded the training data, this would be a good time to do that. Specifically, the head SQ VTI, that's it's a large data set, not so large that you can't download it, but sometimes it takes a little while. So if you haven't downloaded either one of them, I encourage you to go ahead and start downloading that now. And don't do like I do sometimes. Remember where you save it to, because that you need to know where you saved it in order to load it into ParaView shortly. Okay, so here are the data sets. So rectgrid2.vtk and headsq.vti. I attempted to upload some additional files. These are small, as you can see, they're text files. And so this is a sample data file that, if time permits, we will go through and I'll walk you through what we were going to do with this. If time does not permit, I will create a short video and make it available, or maybe even go over it tomorrow briefly before the hackathon. But don't worry about not having access to these text files right now. It is more important right now that you have downloaded the other two VTK file and the VTI file. And so this gives me an opportunity to point out that the different file formats that VTK, that ParaView will recognize. So we're going to be looking at a VTK file and what's called a VTI file. And so one of these files is very readable, which we will look at shortly. And the other one is machine readable, which means if you got inquisitive and you wanted to know what it looks like, perhaps you even double clicked on it and maybe it opened, maybe it didn't. We will take a look at what to do if it didn't open, but no worries right now. So one thing that we're going to do, the first thing we're going to look at is that first file. So we are going to load a data file. We are going to extract some surfaces, isosurfaces, from the data. We will create some contours, some clip contours, slice contours. These are those techniques that I mentioned before that every scientific visualization application should afford you the opportunity to do with your data. We are going to do some volume renderings, which means to create a visualization of the data in the 3D window. We're going to save your data. You may be thinking, okay, of course, you're going to save data. There are different stages of this data, different elements of the data that you can save. You can save the environment. You can save the state of the process that you created. And so we're going to take a look at that as we go forward. I was hopeful that we would get to a section called Getting Your Data into ParaView. I've always found it to be useful when I've gone to workshops to leave there with some knowledge of not only how to load sample data that has been provided for me, but also to have some idea of, okay, you've told me that I can get my data into ParaView. How do I do that? So again, if we run out of time today, I will make the slides that will walk you through this process of getting your data into ParaView available to you as well. Also, an introduction to ParaView and Python scripting. This may be something that we might consider doing at a later time. This would definitely be considered something more advanced. So today we will see how far we get, but regardless of how far we get, I will have some additional resources for you to consider as you go forward from this workshop today to try to get your own data into ParaView, and then also to play around with some of the data sets that are provided with the ParaView package as well. So you can see my ambition here. So much, again, I wanted to share with you. We will get it done in some form or fashion. So again, let's revisit this. Resetting ParaView, the undo and the redo buttons, very helpful. But if you are certain that you just want to start anew, you can always close the application and start again. But there's a shortcut to doing that. You don't necessarily have to close it completely out. If you go to the edit menu or edit button on the toolbar, there is a option, a feature that says reset session, or you can do Control R. So the system, being as smart as it is, it will ask you, are you sure? It will also tell you that once you push this button, everything will be lost. Everything in the sense of whatever you have, whatever pipeline you've created, and whatever data that you've loaded into ParaView. Now, it's not going to delete your data, the original data file, but whatever state of the application that it is in, once you do reset session, it will start you back with the default. So this might be helpful. We will definitely use this a few times today, but just want to point this out to you. If I say, delete all the objects, you can either manually delete them by selecting the object and then clicking on the delete button, or you can just do edit reset session. And what that will do, it will give you a blank slate, so to speak. So now what we're going to do is to open up that first data file. And so hopefully you have saved it and you know where it is. And so I encourage you not to do the double clicking thing. I want you to walk through this process of clicking on locating the file. So you're going to click on File and then Open, locate the file wherever you have saved it, and then you want to click on it, and what you should see is a new object should appear in the pipeline browser. And what ParaView does is it recognizes, your file name, and so that you can see it, that is your data file that we just loaded. And you can see it has the .vtk file extension, which is good. That means it recognizes it. And so you should see, or maybe not, you should see a little box, bounding box in your 3D viewer. And so again, anything that appears in that viewer, you have the functionality to rotate it. Remember, it's 3D, so you can rotate it around. You can look and see. There's nothing in there now, but there will be something shortly. So this is what you should see if you are following along with me. What does that file look like? Remember, I talked briefly about of those two files, the rect grid2 file and the head sq.vti file, one of them being readable. So if you were to open up that file, looks very much like a text file. And so you can see what it looks like. You can see a very simple .vtk file. And so they get way more complicated than this, but I just wanted to give you a view of what a VTK file looks like. If you are inclined to take a look at the documentation that ParaView provides, they do provide, I think, an entire chapter or so, and maybe even more, on the elements of the file so that you can see what you would need to do or what it would look like. This is very much a readable file, so this we can make some sense out of. If we were to open up the other file, which is a little bit more complex, it would not be in human readable form. So in my quest to be thorough, I just want you to be able to see what a VTK file looks like. So I'll go back just for one moment here. So in the content that I will most likely share with you after the webinar, we would actually go through and actually create a file, a sample file. And so this would be one of the things that we would do as an advanced move, so to speak. Okay, so we have our file in ParaView. It is recognizing it, and so we want to do some things. So the first thing we're going to do is to create an isosurface or multiple isosurfaces. So what is an isosurface? It's also called a contour. So the contour shows, or it extracts the points, the curves or surfaces where a scalar field is equal to a user-defined value. So as that description describes, we will be putting in some values here, and we will be taking a look at what results from that. So if you will, make sure that your object in the pipeline browser is selected. So that means make sure that it looks just like it looks on the slide here. It has the little blue background around the file name. And then what you want to do is to click on Filters, Common, and then Contour. Now, there are a number of different types of filters that are available here in ParaView. Again, we're only looking at a few of them, but we're going to follow along with this. So your step would be, make sure you have the file, the data file loaded, rectgrid2.vtk, select Filters, Common, and then Contour. What you should see is a new object has appeared in your pipeline browser. And by default, it calls it Contour 1. So it will give it the name of the filter that was applied, and that becomes helpful too as you are exploring the different things that you can do in ParaView. So you can also rename it as well. Remember, I said you have that functionality to rename it as you see fit. What I want to point out is that right now there's just one value in your isosurfaces section. If you don't see the isosurfaces section by default here, remember you can always scroll down, or you can use the search box if you want to and start typing isosurfaces, and it should bring it up. I typically like to scroll down just to see what's there, but you should see it shows you the range of values that it has identified in the data file, which ranges from 0 to a maximum of 10.3964, but we only see one value there. And so you may or may not see something in your 3D window viewer, but if you do, only those points that have that value is what is shown in your window. So we're going to play around here. We're going to adjust some things to see, can we bring up some other elements as well. So hopefully you have identified or located the isosurfaces section. You see that there is just one value there. So what I want you to do is I want you to select it. And of course, if I'm telling you to select it, we're probably going to delete it. And so that's what I want you to do. I want you to delete that value. And you can do that by clicking on the minus sign in that interface there. And so that will delete it. Below the minus sign, there is a little scale icon or button with a little scale on it. If you click on that, something else will come up that says generate number series. And so this is where you would go in and put in a range of values that you want to see. We're just going to take the default right now, if you're following along with me. We're not going to change anything right now, but feel free to do so if you want to. But just again, remember that your output will look slightly different from what's in the slides here. So we're going to take the defaults that said, show me number of samples 10. We're going to keep the range as it is, and we're going to keep the type as linear. And so what I'd like for you to do is to click on generate. And when you do that, you're telling ParaView to generate the range of numbers, give me 10 values within the range of values that are acceptable for this particular data set. And so your value range box now should contain more than just that one number that we had before. And so hopefully this is what you see, range of numbers there. And because if you've already clicked on the button that said, apply these changes automatically, you should see something that looks like this or similar to this, or you should see something in your 3D viewer now. And so again, I want you to use your mouse to rotate the output, rotate it around. Some of you may be asking, oh, what is this? I want you to focus more so on applying these techniques. This is just to get you familiar with the techniques so that when we take a look at the more complicated, more complex data set like the head SQ data file, that way when I say apply, change the range of values, you'll know what to do. So I want you to focus more so on familiarizing yourself with the steps. So if you take a look at the different isosurfaces, the properties, that's where we were. This slide is to summarize, what we're about to do, what we've done. We're also going to take a look at changing the color of the output that's in that window. So some of you may already have color. Color has already been applied automatically. If it hasn't been, these steps, by changing these properties, it will allow you to give you some color to what you see in your window. And so if you scroll down, make sure you're in the properties section as it's seen in step 1. If you scroll down to coloring, or if you want to type in coloring in that search box, it should bring up those features for the coloring section. And you want to make sure that you have the option set to vectors. And so this is what you should see. This is, again, a summary of steps, what we've just done. We created a new object for the current stage, where we are now. We clicked on Contour 1. We wanted to make sure that that's what we are applying, well, actually Rect Grid 2, and then we clicked on Filters Common Contour, which created the Contour 1 object in the pipeline browser. We then adjusted the range of values by deleting that one value that was present, and then we accepted the default values for now. And then if it didn't automatically apply those changes, you could always click the apply button. We then went and we played around with, or we adjusted the color properties by making sure that the coloring was set to vectors. And so you should see something that is no longer gray, because the original one, as we loaded it in, was gray. So you should see something that looks similar to this, with a little color scale, so that you can see the magnitude of the vectors that's represented there. So that's what we have done. Now, what we're going to do is we are going to create a clip. So we just applied a contour. Now we're going to clip the isosurface. So a clip intersects the geometry with a half space, which means that the effect is to remove all of the geometry on one side of the user-defined plane. So now we are getting into some really interesting things here. So what you want to make sure that you do in this next step is to make sure that Contour 1 is selected, or if you have renamed Contour 1, whatever you called it, make sure that it is selected. And when I say selected, make sure that it is highlighted. Not necessarily where you can go in and rename it, but just make sure that it's selected. And for the purposes of, orientation and making sure we're looking at or have the same perspective, set the view direction to the +Y direction. And so there is a button at the top of the window that says +Y. If you click on that, it will automatically set the view direction for you. Or if you feel like you can set the direction on your own, you can always rotate it to that direction using the mouse. So when you do that, it should look something like this. So this is our view that we should have, or something similar. We want to create a new clip filter, or to apply a new clip filter. And so what we're going to do is we're going to select Filters, Common, and then Clip. So all of the things that we're doing typically will start with the menu that says Filters. So you want to go to Filters, Common, Clip. And when you do that, what you should see is something called a clipping plane. The clipping plane actually shows you a red line and an arrow going through the data set. And so in this slide, you see that the arrow is going from left to right. If you do not see the clipping plane, then you can click on the properties, and then there is a little button that says Show Plane, which is right below where that red circle is on this slide. So that allows you to toggle on and off, or to show or not show, make it visible or not visible. If you don't see the clipping plane, make sure that that is checked. Once you see the clipping plane, what we're going to do is you are going to rotate that clipping plane. And so typically what I like to do is to rotate the plane, or rotate the arrowhead. So this is how you're going to rotate the plane. And this is going to allow you to position the plane where you want it to clip. So using the mouse, hover over the arrowhead, and it will change color so that it will let you know that it has been selected. And if you're using the mouse, you want to press the mouse button and keep it pressed while you rotate the clipping plane, which means you're going to rotate it in whatever direction that you want. I like to rotate it so that the arrowhead is pointing out of the screen towards me, but you can position the clipping plane wherever you like to, or wherever you feel is comfortable for you. Now we're rotating this, but you can move it in any direction that you want. That's one of the nice things about this. And so if you're following along with me, you want to grab, using your mouse, hover over the arrowhead, press it so that it changes color, keep it pressed, and then rotate it around so that it points towards you, or points out of the screen towards you. And so this is what it might look like, or should look like. I've tried to capture a few screenshots. So as you are rotating this around, you will see how the view changes. You can also look above. You can rotate, your entire bounding box. And one of the nice things about this is that you can also move that clipping plane in any of those directions, any X or Y direction. So you can move that plane forward towards you, or you can move it backwards away from you. You position it wherever you want, that you feel like that's where you want the clipping to occur. Once you have positioned your clipping plane where you want it, click Apply, or if you have select or click the button to say Apply automatically, you should see that the plane has been clipped. Remember, what this does is it shows you just that part of the plane that you've indicated. The rest of the data behind that clipping plane is no longer visible. It is still there, it is just not visible. So what if you clipped it and you thought, wow, that's nice, but that's not the side that I wanted. I wanted the other side. Do you have to go back through this whole process of repositioning the plane? If you're confident the plane is where you want it to be, there is an option that says inside out. And so what you would need to do is to locate that option that says inside out. And if you click on it, it will, in a sense, flip it for you, which means it will show you the other side of your clipping plane, if in fact that's what you had intended to see. So that becomes useful too, helpful as you are working through this. Sometimes you will say, well, I want to see a different version or a different side of this. Applying that will help you to do that. So this is the inside out feature showing you on both sides what it might look like. Remember, you can rotate this plane at any time. So if you decide, I don't want the arrow to be pointing out at me, I want it to be pointing to the left or whatever, you can go ahead and you can make those adjustments and it should automatically update. If it doesn't, then either do the apply button or make sure you can do the inside out and it will show you different sides of it. It's a very nice feature, especially when you start to have multiple layers. Okay, here's a summary of what we just did. So we applied the clip function or feature filter, which created another icon in our object in our pipeline browser. We clicked on the apply button. If we didn't see the outcomes, by default, it should be automatically showing you. And then we played around with switching the clipping planes. So you could do inside out to look at one side versus the other side. So there is also something called a slice. So sometimes you may have some data where you don't want to look at the entire part like we just saw, the clip. You just want just a tiny slice of that data. And so what a slice does, it intersects the geometry with a plane. The effect is similar to clipping, except that all that remains is the geometry where the plane is located. What does that mean? Let's take a look and see what happens there. So one thing that you want to do, I want to point out, you should see some little icons that look like an eye for each one of the objects in the pipeline browser. For now, the eye next to contour 1 is kind of grayed out. So that means it is not visible in the 3D window. So anything that is visible in the 3D window is not grayed out here. That icon for it is not grayed out. So what we want to make sure that for this next section that we're going to do, we want to make sure that the rect grid 2 icon, eye, is visible and that the clip 1 is visible. But we don't want the contour 1 to be visible. It will still be there. We just don't want to see it right now. So how to make it invisible? Just click on it and it will toggle. So you can toggle by clicking on it once to turn it on or clicking on it once to turn it off and to go back and forward that way. So this is what you should have, is that rect grid 2 should be visible and clip 1 should be visible in your 3D viewer. If you have anything other than that, you want to make sure that you turn it off so that it's not. So this is what you want to do. You want to click on or select the clipped object, go to filters, common, and then slice. Before we've done contour, and then lastly, we just did clip. Now we are going to slice through this data. And what you get is another plane, but this time it's called a slicing plane. So you should see a new object appeared in your pipeline browser called Slice 1. And you should see the slicing plane with the arrow in the window, the 3D window. And so we're going to do the same thing we did before with the other plane, is that you're going to rotate that arrow so that it points in whatever direction that you are comfortable with. My preference is to rotate it so that it's pointing out at me. But you position it where you want it to be, and then once you release the mouse button, it should automatically create a slice of wherever you are in that data set. If it doesn't automatically do it for you, then click on the apply button. And so just like before, I have captured a few slices here so that you can see. One of the things I'm trying to show with this is that, so you may have, wherever you placed your slicing plane, that is going to determine or dictate what you're going to see in your window. So if you don't see anything as a result, then your plane was probably sliced the data at a point where there wasn't much there to capture those contours. So you can move, remember I said before, you can move that plane forwards or backwards as well. So if you want to move it forwards or backwards, just use your mouse to capture or click on and keep it pressed one of the edges of your red bounding box there, your clipping plane, and you can move it forwards or backwards. You can also rotate this by releasing that and rotating the entire box. So hopefully you can see the differences here. Sometimes you may only want to see the contours as opposed to the outlines. So you just want to see where those points actually hit, but not necessarily all of the data points within it. And so this just gives you a different view. So now I see that we are approaching 4 o'clock. I am okay with continuing. If you guys get to a point where you are not okay with continuing, just let me know. And like I said, I will always add whatever I don't get a chance to go over today to the website. So I'm going to continue until I hear otherwise. So this is what we just did. This we sliced through an ISO surface. So we created a we selected the clip filter, we selected common filters, common, and then slice. We positioned the slicing plane, and then we applied the filter. And so what you could see, as I mentioned before, the output intersects the geometry with the plane. And so this is, think of it as a slice of pie, if you will, or a slice of pizza or something that's just a small representation, the contours or those exact points at where those lines intersect is what you're seeing here. So what have we done? We've read our file into ParaView. We've created a contour, we've created a clip, we've created a slice of the data. And again, it gets back to our 3 basic steps. First, you want to read in the data, you want to filter the data, and then you want to render the data. And so by setting the feature in ParaView to automatically update, the rendering is done for you as you work through and you apply these different filters. So our data file was rectgrid2.btk. We applied the contour filter, we applied the slice filter, and we applied the clip filter. So that was with a simple data set. If you have the time, how about we take a look at a more complex data set? This is just a review slide again. Let's take a look at the headsq.vti file. What I'd like for you to do is to reset your interface, which means we want to clear the environment or the state right now to where it is where we first started. And so if you will go to edit and then reset session, you should see something that looks like this. We are starting anew. What you need to do is locate the headsq.vti file. So if you, by chance, just double clicked on it and something strange happened or it didn't load, that's one of the reasons why I said before, if you did that, there's a process that you need to go through to ensure that it is actually loading in. And so this is a surefire way to do that. Otherwise, what you'll need to do is to associate the file extension .vti with ParaView in your system. That is beyond the scope of what we're going to do today. But if you follow these steps in terms of loading the file through ParaView, you should be able to locate it and it should recognize it. So once you locate the headsq.vti file, as we've done before, you should see the object appear in the pipeline browser. And so it should say headsq.vti. If it does not, click on the apply button. What you should see is your bounding box. So there should be nothing in there right now because we're going to go through and we're going to set some properties to extract some contours, and we're going to, guess what, create some slices, and we're going to create some clips so we can see different aspects of our data. So you should see our one object in the pipeline browser in our bounding box in the 3D viewer. What I'd like for you to do now is to click on Filters, Common, Contour. similar to what we've done before, but now we're going to see a more interesting data set here and something more recognizable. So you want to click on filters, make sure that the head SQVTI object is selected, click filters, common, contour. Again, just a reminder, contours extracts the point, so the contour filter extracts the points, the curves or surfaces where a scalar field is equal to a user-defined value. The surface is also called an isosurface. So you should see that a new object appeared in your pipeline browser. You should also see that there, just like before, is just one number that is in the value range. So we are going to play around with that number and see if we can extract something from this data set. So you may already see something in your 3D viewer. If you do, that's fine. If not, we're still going to set some values there. So just like we did before, I want you to, you're going to delete that value that's there. If you haven't already done so, if you've already deleted the value, if you can do an undo right now, that would be great. If not, no worries. I just wanted to show you something. I got ahead of myself. But if the value is still there, you click apply and you should see something in your pipeline browser that looks like this. It should looks like a skeleton or the bones of a skeleton. And so, you know, in keeping with the title and the name of the file, it is a head. It's a skeleton. Take your mouse and rotate it around so you can see the insides of what you see in your pipeline viewer there. It's pretty neat to be able to see that. So now what we're going to do is we're going to play around with the values so that maybe we can extract some specific things from this particular view. And so if you explore the data set, I've captured a few views, screen captured here, so you can see different sides from the top, you know, bottom. It's kind of a neat thing to actually see there. You can play around with visually exploring the perspectives. You can do x-axis view, y, those types of things. Again, this allows you that functionality, or you can use your mouse to rotate it as well. If you don't want to use the mouse, or you don't have one handy, but you still want to look at it from these different perspectives, those buttons will allow you to do that. Okay, so there are two objects in the pipeline browser. What we're going to do is we're going to play around with the value range. And so it has recognized the minimum value in this data set is 0 and the maximum value as 4,095. And there's only one value in the box right now in the value range. And so what you're seeing in your viewer are points that correspond to that value. So I want you to, just like we did before, to select that value, that one value, delete it, or press the minus button. And you're going to get a value range box that looks slightly different from what's on here, but you can, excuse me, select the, pardon me, you can enter in, you can play around with the values there, or you can take the default and click on generate. And so when you do that, instead of clicking OK, it would say generate. It should create a number of values there. Depending upon what you put in there, if you kept the default step values of 10, it will show you the 10 values there. And so what you should see, if you don't already have this in your viewer, you should see your Contour 1. This is what you should see in your pipeline browser. You should see something in your 3D viewer window, and you should see the range of values in the value range box as well. If you don't, then click that apply button, and it should force it to apply and render what those values represent. And so it may take a few seconds depending upon the speed of your device that you're using, your laptop or desktop. You should see something that looks like a human face. So we've actually told it to pick out the values that correspond to skin. in this data set. So initially we were just looking at the bone because that number, that one number, mapped to data points that represents bone in the data set. And so by expanding the value range, we're able to see, to overlay the skin on top of our skeleton that we have there. So take a moment, rotate it around, see what's in there. Like I said, it's an interesting data set for you to explore, far more interesting than the first one. I have captured a few screenshots here to just kind of gather, to let you see what it might look like if you haven't been able to render it on your own device there. And if you wanted to see what the properties are for this one, remember the first data set that we looked at, we could actually open up the file and read it and make some sense out of it. But because this is a binary type file, it is only machine readable, but ParaView does a great job of extracting some metadata from that file so that you can make some sense of what's there. And so if you click on the information tab, which is right next to the properties tab, that gives you, it summarizes all of the elements of that file that that ParaView has been able to detect. And so this gives you an opportunity to see how that data is represented. It gives you the range, it gives you a lot of information. I just took a short screenshot here. But what's interesting to see, remember we talked about the different data types. So this would be considered a polygonal mesh. And it tells you the number of cells that are there, it tells you the number of points that are there, and it tells you how much memory is being used for the slide and for the data. Also be thinking about every time we apply a filter, remember you are creating a smaller subset of the original data set. So I am stressing that because I want to make you aware that that original data set is still there, loaded into memory. When you create a filter or you apply a filter, that original data set is still there, loaded into memory. You have just added to the amount of memory that is being used now by applying that filter. So if you apply a lot of filters and you start to notice that your machine is slowing down of some sort, you're probably using up a lot of the memory a lot of your RAM in your device there. So you may want, if you're going to be working with a large data set and you are not using high performance computing resources on the end to do the workhorse part of this, then you may want to make sure that you have no other applications running so that you can have access to all of the resources that are available on your device. So just some steps that you can take to do that. So you should see something that looks like this. Again, this is just kind of a summary to let you know where you should be if you're following along. We should see a much more interesting rendering in the 3D viewer now. And so what I want you to do is to play around with setting some values. And so hopefully you remember how to go back and set those values. If you don't remember, what you can do, let's see if I've got it here. Yep. Is you want to remove all of the values in your value range box. So you can delete them one by one, but who wants to do that? Or you can delete them all. And so at one time. And so there is a little X box there, a little X that will button that will allow you to remove them. And then what you will need to do is you will need to go back in and actually set some values there. And so once you get to the place, that little icon that has the scale, which is right above the delete button, or the box, the button with the X. Once you get there, you will go in, you will type in some values, and then you will click, instead of apply, you will click on generate. And so just kind of getting there where I am working towards. This is where you should be. And then what we're going to do is I'm going back for a second, I apologize. Once you get here where you set the values, I want you to set some of these. You don't have to do them all, one or two. Set the values to go from 1500 to 2500 with a step of 10. And so as you are playing around with these different values, what you should see are different features that become prevalent or that are showcased in your 3D viewer. So because I want you to figure out or to see what it is, I'm not going to tell you what you should see, but I will say if you play around with some of these values, you will see different features of that data set. Some of you may see a more defined jawline. One of them may show more hair on the representation there, so you'll have to rotate it around. So at your as an exercise later, um, because we are over the time, I encourage you to down with these settings and just to see what you discover. I think you'll find it interesting. Okay, so in the interest of time, and I do apologize for keeping you over our allotted time, I am going to stop here, but the slides, hopefully you do have access to the slides and you can work through the remaining slides because just like the pace that I've gone here, it's literally at the same pace. So you should be able to step through each slide with explanations clearly stating and showing you what you would need to do in order to apply the clip filter and the slice filter, which will allow you to slice through this data set and give you a much more interesting view than what we've done so far. And so as I'm talking through this, just trying to show you what you will see as you rotate those planes around to either point in whatever direction that you're interested in. And I do encourage you to play around specifically with this one because it will show you different aspects of this data set. And this is a far more interesting data set than the one we started with, but it's to give you an idea for what's there. If you don't see the results, remember, you can always click on that apply button. If you think you've applied it and it should be showing something that you're not seeing, click on the apply button. That will force the algorithm to actually show you the results. And in this case here, you can see my clipping plane actually clipped the ears of the data set here that we can see. Otherwise, we would not have known that any clipping actually took place. So again, as you work through the slides, I have organized them in such a way at the end of each section, there's a summary slide. So if you want to work through it and you want to just go directly to the summary slide, you don't want to go step by step, the slides are created in such a way that it will allow you to do that. And so again, you go through here. I'm going to fast forward a little bit so that we can get to saving your work. So as I mentioned before, it's not just a matter of saving a file. That, of course, you can do. But because you created an environment or a state in which you are working in, ParaView allows you to do that. So you can save the state that you're in, which means that any of the filters that you've applied, maybe something comes up, you need to step away. You want to make sure that you get back to where you left off or where you stopped. If you save the state of your work, you can reload that state when you start up again, and it will bring you back to where you were. So that some of you will find will be very useful as well. Of course, you can save the data. You can save screenshots. You can export scenes. You can create animations. You can save the geometry. So there are a lot of things that you can do, a lot of ways in which you can save your work that you will find will be beneficial as you get more involved and start working with ParaView. So here are the steps that you can do, or just like I said, the options there for saving your work. If you want to save what you've worked on today, you can play around with saving the state and saving the data and saving each one so that you can see what actually happens. Then I encourage you to do that as well. There are always shortcuts. You can do Control-S, and I think that will save just the data. But if you want to be more specific and change and save maybe your state, then you'd have to go through the menu as shown there. Here is a screenshot menu that will allow you to adjust the resolution. So hopefully you can see that the ParaView is a very powerful package and allows you to do a lot of different things. And I hope that this has helped you to start thinking about what you can do with your data. Again, there is a lot of content that we did not cover. My apologies again for not being able to go through all of these slides, but I will make the content available with narration, with my voice, to walk you through the process for the remaining section. So with that, I'm going to pause here, or I'm going to stop here and go back to, if I can get to the end of this. Oh, it's not there. To show you what's coming next, which is, so one second here. So wrapping up, there are some additional resources. Again, this clearly didn't cover everything that could be covered with ParaView, and with this tutorial, it was kind of a quick view of it. And I want you to be aware that there are some even more advanced resources out there that are available to you for those of you who are interested. The ParaView website is a very good resource for you. There are online things that you can join. If you're new to ParaView, then whatever you're running into, or whatever challenges that you're facing, chances are others have faced it too. So there is a very good knowledge base available to help and assist newbies like yourself. There are help menus in the application itself. So there's the ParaView guide, there's the helpline, there are online tutorials, there are online blogs, so lots of resources. So what's next? Hopefully you will join us tomorrow, where we will have a visualization hackathon. So you have been here with me and my co-organizers the entire week. What we hope to do is to give you an opportunity to bring your own data and get some feedback and some assistance from us to kind of help you in trying to utilize the tools that we've gone over and introduced today in this week with your data. So that being said, I do encourage you to take a look at the website. There will be a feedback survey for you if you're interested in getting access to the worksheets that were demoed on yesterday or shared yesterday. You'll need to complete the survey, because at the end of that, it gives you details on how to request the worksheets. So I look forward to any questions that you might have. I'm going to ask that you post them, or there's a web link on the main page that will allow you to post questions, and I will address them and try to have them answered in time for tomorrow, so that if there are some ParaView related questions, I will address those then.
So I'm not sure if Dr. Aurora is still on. Are you still on here, Dr. Aurora?
Yes, I'm here.
Oh, okay. Would you like to take it?
Sorry, I'm having some issue here.
Okay. Well, I can take it. So, so Dr. Burge, one final question, and I think we spoke about this earlier.
Okay.
Julian is asking if the recordings are going to be available on the website. Would you mind addressing that?
So yes, thank you so much for asking that. So the recordings will be available on my YouTube site. I do ask that you give me a few days after the webinar ends. I am a party of one here with competing obligations. And so what I'm going to do is, once we have all of the recordings, is I will make them all available, and also update the frequently asked questions that people have been sending in. I hope to have all of that done this weekend, so that you will have access to that.
Okay, it doesn't look like there are any further questions. I did copy a few, and Dr. Bird, I'll be sending those to you tonight.
Okay.
As you mentioned, you'll post them. when you
Yes.
have time.
Mhm.
But on behalf of UTSA and Dr. Aurora and myself and everybody attended, thank you very much, and we hope to see many of you tomorrow.
Yes. Thank you so much.
All right. Goodbye, everybody. Have a good afternoon.
Bye-bye.